In this module, we're going to mark the different areas for easier processing in the coming modules. In this clip, we divide our structure into corridors and gateways. At the moment, our basic framework consists of the create corridor network and then another subnetwork where we have the conversion into VDB and the caching operation. Now, for the next step, I want to create another subnetwork. So start with a null and turn it into a network. Inside of that network, I want to define which area has what type. So I call it mark areas. So let's jump inside and see what we got. On the points, we have of course the position and normals. But on the primitive, we have the attribute tile, which tells us the basic purpose of each primitive. A wall, a ceiling or a floor. So let's use that attribute to break it down. Create a blast node and only keep the primitives that have the type wall. That makes it much easier to differ in a corridor or gateway. Later, of course, we will also need the floor and the ceiling. So I'll drag this blast node and just change the tile from wall to floor. Copy it another time and this time for the ceiling. And again, if you already know your project will grow quite big over time, it's a good idea to always name your nodes. You will thank yourself later. So in the first step, I want to mark the corridors. And since I do that with only the walls, having the corridors also gives me all the gateways. The general idea is to shoot from one side of the corridor over to the other with an intersect. I know that my corridors are 4 units apart, while the gateways have 8 units between them. Let's display the points and the primitive numbers and set the wrangle to primitive. Again, we will need the points from each primitive, so we use prim points. And then we need a few variables, like 2 vectors for the intersect, the result of the intersect, and another vector for an original position. And we need that position because I want to find the middle of the primitive. To do that, I'm going over each point with an for each loop and then add the values of each point into the vector variable origin. Then I'm going to divide the vector by the amount of points the primitive has. If I did that correctly, the new position of origin should be the center of the primitive. Just to check if that worked, I'm going to create a new point at this position. And without the primitive numbers, we can see the new points. Now, as you can see, the normals are pointing outwards. But for the intersect, I have to go into the opposite direction. So I just take the normal from the first point of each primitive and reverse it by multiplying it by -1. Now I can do my intersect. I use the origin position, the normal that is facing to the other side of the corridor, and multiply it by 4. Then I create a string variable and then check the result of the intersect. If the variable inter, which holds that result, is -1, the intersect hit nothing. But if it did, we can be sure that we hit a corridor. And to give us a very easy visual clue, we now paint each point of this primitive red. Just set the point attribute color in a for each loop. Now I could just continue the if statement with an else, but in this case I just want to check if the structure is not equals corridor. Other condition, same result. All the primitives that are not corridors can only be gateways. Of course I also want the visual clue, so I copy the for each loop and this time I choose the color green. So before I apply this, I need to save the string variable structure in a string attribute. Now it looks like all of our primitives are seen as corridors. And the reason for that is the same as with the blocked entrances. The intersect function starts and immediately hits its own position. We have multiple options to solve it. One way would be to use the peek node. It allows us to move each primitive by just a small distance. Just enough to create a tiny gap, like this. Then we use the peek geometry as new first input of the wrangle and then connect the origin structure into the second input. Then all we have to do is change the intersect from the first to the second input. Now the intersect can work properly and we can see that indeed the gateways are not recognized as corridors. But of course if we use this way, we need to readjust our primitives by using another peek node to negate the first one. As you can see, subs are well and good, but sometimes using vex is just easier. So let's delete the peak nodes and cut off that second input. Turn the intersect back to the first input, and then we're going to add one line of code. On our origin position, we add the normal vector times 0.1. As with the entrances, we just push our point a tiny bit towards the direction of the normals. We can still see the points directly on the primitives, but only because we added the point before we pushed them in. If we add the point after the move, you can see how we manipulated the position. But now that we know it works, we don't need the point anymore.